This is problem 8-151 from section 8.3.2. Sketch both the circle x squared plus y squared equals 25 and the parabola y equals x squared minus 13. So sketch of these, you can use your graphing calculator if you want to, but a sketch, I know my circle is going to have a radius of 5, so that's going to be my circle, and my parabola is going to be, whoops, down 13 is where it's going to start, so we'll pretend that that's down here somewhere, and then it's going to go like that. Okay. So use your calculator if you want to get a more specific graph, but a sketch, as long as we're getting the visual idea of what those two things look like. Part A, how many points of intersection are there? Well, if you check on your graph to make sure, but on our sketch we have 1, 2, 3, there are 4. Part B says find the coordinates of these points algebraically. Right, so I have two equations and I want to know, when are they going to be the same? Right, that's what the intersection is. So I'm to algebraically solve these. I know y equals this stuff, and I have a y in that equation. I'm going to do substitution and replace that. So x squared plus this quantity squared equals 25. Well, the quantity for y is x squared minus 13. Oop, ahead of myself. Minus 13. Okay, so I'm going to square both of those things, which really does not just mean this quantity squared and this quantity squared, right? I got multiple things in between, so I'm going to have x to the 4th, negative 13 times x squared, and another negative 13x squared, which will be negative 26x squared, plus 169 equals 25. Okay? So that's what we have so far. So if we move everything over to the one side instead of equal to 0, combine our like terms, we'll have x to the 4th. Let's see, I have a minus 25x squared. And if I move that 25 over here, I'm going to end up having positive 144. And that equals 0 now. Alright, so I'm trying to find the coordinates. I want to find what x is. I got rid of the y's, I'm going to solve for x, and then I'll end up plugging that back in. So what we can do here is we can factor this. Okay? So if you want to do the rectangle, you can. Rectangle and diamond, I know x to the 4th. And I have 144, so this needs to be 144, x to the 4th is going to add to be negative 25x squared. Okay, so things that multiply to be 144, we could have possibly a 9x squared and a 16x squared. Now those together added make up positive 25, but I need them to be negative 25. So I'm going to put a negative in both of that, and that still works. So I have negative 9x squared. I have negative 16x squared. Okay. Find the outsides of the rectangle would be x squared minus 9, x squared minus 16. Okay. So if you want to use the rectangle, you can to still solve this. So I have x squared minus 16 equals 0. I'm going to solve that, and I have x squared minus 9 equals 0. If I solve that, I'm going to have x equals the square root of 16, which could be positive or negative 4. Whoa, that was terrible looking. Let's fix that. X equals plus or minus 4. And for this equation, I take the square root of 9, which could be positive or negative 3. So I have 4 different options for the x values, okay? Which I should see that makes sense. But for my y values, if you just look at the graph, these are about the same height, and these are about the same height. So I should probably only have 2 y values. But I'm going to plug these in to one of my equations. And I think the easier one to plug it into was the parabola. So I'm going to plug in my x values to that equation right here. So y equals, let's say plus or minus 4. Let's just write it like that. Because either way, I still get a 16 minus 13. So that point would be plus or minus 4, comma 3 was my y value for that one. Okay. And if I plug in the other point, so y equals negative plus or minus 3, sorry, squared minus 13 And then I have 9 minus 13, which gives me my point would be -4 for that one. Okay. So I have those two answers right here. Those are the intersections. There are 4 intersections, so I could write all of those separately if necessary. Write all those separately out. But that's going to be my 4 points of intersection. So we did substitution to find those based on our original graph that we sketched, the circle and the parabola.